The sine of theta is 0.5. If we write 0.5 as a fraction, we know that that's going to give us a ratio of 1/2. We also know that the sine ratio is the opposite side divided by the hypotenuse. So for every right triangle where my hypotenuse is double the length of the opposite side from this angle will be the same measure. No matter how large or how small that triangle gets, we can see that the hypotenuse is always double the length of the opposite side for that angle. So to get the measure of that angle, we want to be in degree mode. So in our calculator, we're going to go into mode and we're going to go down here. We're going to press enter on degrees so that black box highlights. We can go second function mode to get out of there. And now remember, anytime we want the angle measure, we're taking the inverse of that sine. So we're going to go second function sine, and then we can enter that 0.5, and that will give us the measure of the angle, 30. So I know that for every right triangle, if I have a 30-degree angle, I will always have a hypotenuse that is double the length of that opposite side. In grade 10, we focused on solving for those missing angle measures in right triangles. We're now going to look for all angle measures in that full 360-degree circle that have a particular trigonometric ratio. So the first thing we want to do is start by getting that reference angle. So we're going to go second function sine, enter that ratio, and that's going to give us the angle. And then we're going to use our cast rule to figure out which quadrants that ratio is either positive or negative in. So we can see that this is a positive ratio for sine. Sine is positive in quadrants 1, where all ratios are positive, and in quadrant 2. We can then go ahead and draw a sketch. So I have a 30-degree reference angle, which is just my angle of rotation in quadrant 1. And then if this is 30 degrees, we can figure out what that angle of rotation would have been when our terminal arm lies in quadrant 2. So we can figure that out by taking that 180 degrees, subtracting the reference angle of 30, and we know that angle of rotation is 150 degrees. So these are all angles between 0 and 360 degrees that have that trigonometric ratio. On the calculator, make sure that we are in degree mode, and then we can even see if we were to take the sine of 30 degrees, we get that 1/2 ratio. If we were to take the sine of 150 degrees, we also get that ratio of 0.5. Let's try another one here. So the first thing we want to do, this is the ratio. We want to figure out what that reference angle is. So we're going to go second function cosine, and then 0.4540. So we're going to enter that ratio. It is in a decimal form, and that gives us the reference angle. So if we round this to the nearest degree, this is going to be a reference angle of about 63 degrees. We then want to figure out where those terminal arms will lie. So we're going to use our cast rule, and we can see that we have a positive ratio. Cosine is positive in quadrants 1 and 4. So we can go ahead and draw a sketch now. So quadrant 1, that angle of rotation is just my reference angle, and then quadrant 4, you can see that if we go around here, we're short of that 360-degree full circle. So we can get the measure of that angle there. And then again, you can always verify this. We can enter the cosine of 63 degrees as well as the cosine of 297 degrees. And you're going to see that this ratio here is a little bit different than this one because we rounded that angle. You're given a ratio in fraction form. Make sure when you find the reference angle, you're taking the inverse of that 2 divided by 3 is how you would enter that, and put brackets around that fraction. And then we can see that tangent is positive in quadrant 1 and quadrant 3. So we can go ahead and sketch those angles, and then we can calculate the angle of rotation for each. Now, if we have a negative ratio, when we're entering this into our calculator, in order to determine that reference angle, we're actually going to ignore putting that negative sign in because some calculators get kind of finicky with that negative. So what you're going to do is just get that reference angle first of all. So you can see that we have a negative cosine ratio. Cosine is positive in quadrants 1 and 4, which means it's negative in quadrants 2 and 3. So we can go ahead and draw our sketch, and then we can calculate those angles. And one more time here. So we have a negative ratio. When we're getting that reference angle, just ignore the negative sign and enter 0.9781, and then figure out which quadrants our terminal arm will lie in. So we have a negative sine ratio. Sine is positive in quadrants 1 and 2, which which means it's negative in quadrants 3 and 4. Go ahead and draw your sketch, and then we can see that here we're going to have 180 plus 78, and then right here we're going to have 360 and then take off that 78. That gives us all measures of rotation between 0 and 360 degrees for that particular ratio. The next thing we're asked to do is to solve for angle A to the nearest degree for any measure of angle A between 0 and 360 degrees if we're given a point on the terminal arm. So we're using an A now just in place of that theta. So the first thing we want to do is plot that point. So we can see we're going -5 and then we're going up 12. That's the point. So the terminal arm is passing through that point. So we want to figure out what's that angle of rotation, and in order to get that, we're going to need the reference angle first. Now we can use any trigonometric ratio, but because we already from this angle know the opposite side and the adjacent side, tangent is the easiest to use. We don't even have to bother calculating the length of that hypotenuse. So we can go ahead and say from that reference angle, our opposite side is that 12, our adjacent side is that -5. And again, when you put this in your calculator, we're taking the inverse of tan, ignore that negative. So just put in 12 divided by 5 to get that reference angle. And if we now know that this has an angle measure of 67 degrees, we can take that 180 degrees, take off the reference angle, and that will give us our angle of rotation, 113 degrees. So again, we're going to plot that point. So -4, -3, there's our point. The terminal arm will pass through that. We're looking for that reference angle. So we know that this is -4, this is -3. Tangent is the easiest ratio to go with. And then when you enter it in your calculator, a negative divided by negative is a positive, so it's kind of irrelevant in this case. Second function, tangent of that 0.75 is going to give us a 37-degree reference angle. So then if we're looking for the angle of rotation, that's 180 plus another 37 gives us an angle of 217 degrees. And our final one, so our last point is 5, -1. So we're going to go 5, -1. That point lies on the terminal arm. So our reference angle is right here. We can set up the tangent ratio, so opposite over adjacent. Ignore that negative when you put it into your calculator. The inverse tan of that 1/5 is 11 degrees. So we have 360 minus 11 will give us that angle of rotation, 349 degrees.